Welcome everyone. Guys, in this video, we will be talking about all the required points about paper 5 regarding enthalpy. So you know guys, for paper 5, we have so many experiments, I think 5 or 6. So these experiments are mainly about enthalpy, measuring rate of reaction, measuring titration also. So today our video or our class will be about measuring the enthalpy change, okay, measuring the amount of energy released or absorbed during the chemical reaction, okay. So the first thing we are going to start with is enthalpy change of solution. So guys, who remember what do you mean by enthalpy change of solution? What was the meaning enthalpy change of solution? Yes, Naima. What do you think? What do you mean by enthalpy change of solution?
Good question.
What? So you don't.
No, I said good question, but I don't remember.
Definitely good question. So yeah, most of you don't remember AS level, but all of these stuff are required for paper 5. All the AS, not all the AS level, the experimental part of AS level, all of it is required for A level. So guys, we took this one by the way, we took this one A level Naima as well. Okay, we took this one this year. So it's the enthalpy change when 1 mole, guys, when 1 mole of a substance, 1 mole of substance dissolved in water, okay? And I think we did the experiment before in the lab. By the way, delta H of solution is the delta H sol, and we have this. This is for the, what is this for?
Standard conditions.
Yes, amazing, Amal. Standard conditions. So look, guys, one of the questions that you will be asked about is measuring the required or the setup of the experiment, okay? This is one of the most common questions. You will be asked what we are going to use to make this experiment, what you will be in need to make this experiment. So this is, guys, what you are going to memorize later on. You have to train on drawing this so many times. So here we have, guys, the plastic lid, we have polystyrene cup. Guys, this polystyrene cup is here. This one is put inside a beaker. Do you know why? Do you remember why? We did this one in the lab, right? Before.
To balance the heat or the temperature.
To minimize or to reduce the amount of heat that will be lost, okay? To reduce the amount of heat that will be lost. Here we have the reaction mixture. Here, guys, we have a label, okay? This is label, and here we should write what the substance in the mixture is. What did we put in here? Okay, so if we put, for example, sodium hydroxide, so we say NaOH solution. Okay, this is the label at worth 1 mark. And the thermometer, guys, should be written like this, okay? A replica of this. So we have this here down below. You have to show it. So this is, guys, the setup of the experiment. So who remember, guys, how did we perform this experiment? So look, we have steps. The steps, guys, you don't memorize them, okay? You don't memorize the steps, but understanding them. In the exams, paper 5, yani, to be honest, I have never seen such a question asking you to write the experiment steps, but usually the steps are given for you, okay? And you have to, and you will be asked about these steps. The steps I'm saying now, you will write them later on after you watch the video once more, and just understand them, just know them. You have to know them, okay? So look, guys, first of all, we take this polystyrene cup, put it inside the beaker, and then we are adding water to it. We are adding water to it. And we measure the temperature of the water. As soon as we put the water inside the polystyrene cup, we start measure the temperature, okay? We measure the temperature for 3 minutes. Okay, we measure the temperature for 3 minutes. As soon as we put the water in the polystyrene cup, we measure the temperature at different period of time, each 30 seconds. Okay, each 30 seconds, guys, we measure the temperature. So it will be like this: second 0, 30 seconds, 60 seconds, 90 seconds, 120 seconds, 150 seconds. Okay, so this is 6 times we measure the time for 3 minutes. So my question is, why should we measure the temperature for 6 times before we add the something that we want to measure its delta H of solution? Why should we measure the temperature for 6 times? This, guys, the step will be given for you. Just 1 second, Marianne. The steps will be given for you, but you are asked this question. Why should we do so? This is one of the most important questions. Yes, Amal, go ahead. Sorry, Marianne.
To ensure accuracy.
To ensure accuracy, okay, but the answer will be,
Find the
guys,
change.
the first 3 minutes, we do not add the material, guys. We want the water temperature be in equilibrium with room temperature. We want water temperature to be in equilibrium with room temperature. This is the reason, guys. Okay, this is the reason. And by the way, this is one of the past paper question. I saw so many past papers, so I brought the questions. Okay, and this question worth usually 1 mark. Right. Let's go back. Just 1 second. Yeah. Look, guys, from seconds 150 to 180, or at 180, second 180, we add the substance that we want to measure its delta H of solution. For example, we add the NaOH. We add whatever you are going to measure at second 180. At second 180. At this second, we don't measure the temperature. At this second, we don't measure the temperature, guys. We measure the temperature here for 6 times. At this second, we don't measure the temperature. And after this, in 30 seconds, I mean in 210 seconds, we will measure the temperature. We will know the reason later on. So you will get, guys, after taking, for example, after mixing the reactant and water and taking, let me say, for 7 results, you will get, guys, such graph. You will get a graph like this. So as you see, guys, here we have the temperature. Can you see the graph? Yeah, here we have the time in seconds. So, guys, we put the water in polystyrene cup here. We measure the temperature. So we have 6 readings here. As you see, guys, the readings are constant. Okay, the readings are constant. Why don't we have a point and at 180? As you see, guys, we don't have any point. Why is that? Because we didn't measure.
We didn't measure it.
Yeah, amazing, Maria. We didn't measure here. At 210, guys, here we measured the temperature. Okay, and when we measure the temperature, we see that increasing in the temperature. So this is a typical exothermic reaction. As you see here, guys, the temperature continue to increase until here, until this second, I think 300 or something like this. Then it falls down, start to falling down. Guys, why the temperature starts to falling down now in here? Any idea?
It's losing thermal energy.
No.
It lost heat.
No. The losing in heat is continuous. Okay, even here we are losing heat. But what happened here? Why the temperature starts to falling down? Why is that? One of the possible questions.
This is after we added the NaOH to water, right?
Yes, yes. All of this
Is
is
it,
after
the
adding
reaction
the
occurs, it's it's endothermic reaction.
guys, we can see the reactant is used up. So so guys, after this, so there is no more reaction. So that's why, yeah, guys, look, paper 5 questions are very simple. When you see the mark scheme, you will be shocked. Okay, and when you see the examiner report, you keep laughing at the answers that the students give. Okay, so that guys, you must solve as much as you can of these papers. Okay, so you will be great at paper 5. So guys, the reactant start to be used up and the temperature decreases. طيب. Guys, don't forget our aim. Our aim is measuring delta H of solution. Delta H of solution. So look, guys, now we took these results. They took so many results here. So many points, sorry. So what will we do? Look, guys, we will draw a line of the best fit here. So the line of the best fit, it will be like this. And guys, I hope you know, when we have such random points, such unordered thing like this points, and we are asked to draw a line of the best fit. So I hope, guys, you know how do we draw it. So it will be something, let me say, something like this. Okay, line of the best fit. Line of the best fit, that the line that passes from the large possible number of points. This is the line of the best fit. I can't draw it now correctly, but later on, guys, after when you watch the video, try to do it in your copybook. Okay, just write the train on this, because guys, you will be asked about this a lot. Each paper, guys, must have a question about line of the best fit. Did you take this one, Mark?
Yeah, it shows negative correlation.
Yeah, right. Sorry. So here we have, guys, two lines of the best fit, this line and this line. Look, guys, from 180, what is this? This is the time that we added substance, time adding of NaOH. This is the time that we added NaOH. What happened at this time, guys? Look, at this time, we will see the line of the best fit of these points. It comes here. It comes almost to, let me say, 36 Celsius. And here it is 42. So I will use these two temperatures to find delta T. I don't know, guys, if you remember or not, delta H, usually that we took, equal to minus MC delta T. So my aim here is finding delta T. After we found delta T, the question is over. How do we find delta T? Draw a line of the best fit here, line of the best fit from these points, and we see to where this line of the best fit reaches at second 180 seconds. Okay, 180 seconds here. So we reach to this point. That's it. So the temperature here is 36. So delta T equals 36 minus what? 24, which is equal to 12. Okay, this is, guys, delta T. We found delta T. So now, yeah. Now what? Look, guys, after we found delta T, do we have any question about finding delta T here? No questions. So, guys, look, here we use a Q equal MC delta T. You have to be familiar with this. Whenever we have a question about enthalpy change, so you will be in need to use this formula. 100%, you will be in need to use this formula. Q equal MC delta T. We don't have a negative sign here. But what is the Q? The Q, guys, is energy or heat transferred, energy made or consumed, amount of heat. Yeah, the unit of Q, guys, always in joule. The unit of Q that we use here always in joule. You must know this to avoid so many mistakes that you made it. Okay, may do. So, guys, don't forget Q here is in joule. M, guys, who remember what was M?
Mass.
Mass, exactly, yes. Mass. Mass of what?
Water.
Amazing, yes.
Water.
Mass of water. Yes, M is the mass of water. Who remember, guys, what was C?
Specific heat capacity.
Amazing. What's the meaning of a specific heat capacity?
How much the temperature of a material increases by each Celsius per kilogram.
Per gram,
Something like this.
1 gram.
Per
Okay.
gram, yes. In
Yeah.
physics, it's a gram.
Gram. In physics, yeah, you are taking physics. Yeah. Okay. But Mariam taking biology, so don't confuse her, please. Mariam and Naima, by the way. So look, guys, now delta T, sorry, we found delta T12. So we say Q equal to M, guys. M is the mass of the water. What did we use? What was the mass of the water? I don't remember. Let me say 70 centimeter cubic. Guys, look, for water, centimeter cubic equal to gram equal to milliliter. All of these for water are equal. Centimeter cubic, gram, milliliter, all of them are the same, the units. So Q equals 70 times 4.18 specific heat capacity of water times the delta T, which was 12. So when you multiply them, guys, use your calculator, give me the answer. What will be? Yes. Mariam will give us the answer.
At 268800.
2688. Yeah, 2688.
00. Yeah.
Yeah, 268. Right. This amount, it will be this amount. The unit, guys, don't forget the unit always in joule. The unit always in joule. So this is, guys, the first thing you are asked about. Whenever we have enthalpy change in paper 5, you will have this equation. Another question, guys, you will be asked about calculating delta H. Now, guys, look. Let me say that in the previous polystyrene cup, let me remind you. Yeah, as I said, let me say that here we have 70 centimeter cubic of water. And let me say that we put 4 grams of NaOH. 4 grams of what? Of NaOH. 4 grams of NaOH. طيب. In here, guys, to calculate delta H, we will say delta H equal minus MC delta T over, now, guys, this is a new rule, over N. N is what? N is the number of moles of the substance. Right, delta H equal minus M, guys, 4.18. Sorry, M was 70. Sorry. M was 70. C 4.18. And delta T was 12, as we said, right? Over N, guys, what's the number of moles that we added? We said we use 4 grams of NaOH. We divide this 4 grams by what?
The molar
Molar
mass.
mass. It's molar mass, which is NaOH molar mass is 40. I hope you know how to calculate it. So Na23 plus 16 plus 1. So this one, guys, gives us 0.1, right?
Yes.
0.1. Yeah. So we put 0.1 here, guys. We put 0.1 here. Right. What will be the answer, Mariam? Calculated.
Negative 35,112. 112. Yes.
Guys, right? So this is, guys, look. The unit now, after calculating delta G, is always joule over mole. Joule for each mole. In Cambridge, guys, they don't accept joule over mole. They need kilojoule over mole, always. So we just divide by 1000, so you end up with minus 35.112 kilojoule per mole. That's it, guys. We're done. Okay. Yeah. So we need, guys, to solve as much questions as you can. Let's take a look on a typical question, and I will bring this question from AS part. Guys, now take a look on question 4A and B. In a question 4A, calculate the energy transferred. What do you mean by energy transferred? We mean Q. When the temperature of 75 centimeter cubic rises from this to this, yeah, so we can calculate the Q. Q, guys, simply will be 75 multiplied by 4.18 multiplied by what?
31.
Really? Right, 31. 31. So it will be what?
9,718.5.
9,700?
18.5.
18.5 joule. Okay, guys, the unit here always joule. You have to see, guys, in the question, what is the requirement unit. If they don't talk about the unit, just the Q, leave it joule. If they want kilojoule, just divide by 1000. We can't find delta H here, guys. Do you know why? Because I don't have any idea about the number of moles. So yeah, it will be difficult to find delta H. When 80 grams of sodium chloride is dissolved in 40 centimeter cubic of water, the temperature falls from, this is endothermic process, from this to this. Calculate the energy absorbed in the solute. Guys, look, now we are supposed to calculate what? Energy absorbed. Is this a Q or delta H? What they want? What do they want?
Delta H.
La, Q. Delta H, guys, only when they say enthalpy change. Only when they say enthalpy change, so we care about delta H. When they say energy absorbed, energy released, amount of energy, amount of heat, we always calculate Q. So let me show you something now. Q will be equal to MC. M was what? 40 multiplied by 4.18 multiplied by what? The temperature falls by what? By 1.5, right? Degree.
Yeah, 1.5.
1.5. Here, guys, we don't include, even if the charge is negative, but we don't include it. We don't put negative. We don't have amount of energy in negative. So the Q will be what?
250.8.
200. What?
50.8.
50.8 joule. Okay, joule.
Yeah.
Yeah, that's it. So the question now is over. This is, guys, all of the possible questions about enthalpy change of solution, delta H of solution. Enthalpy, guys, has so many experiments. One of them, solution, neutralization, enthalpy change of neutralization, enthalpy change of combustion. So on the next topic, we will talk about the enthalpy change of solution. Welcome back, guys. So now, guys, we are talking about enthalpy change of neutralization. So, guys, who remember the definition of enthalpy change of neutralization? Idea?
Acid-base neutralization reaction.
So, guys, is the enthalpy change when 1 mole of water is made from reaction of acid and base. We have 1 mole of water. is made from the reaction between acid and base. So here, guys, to do an experiment like this, we will need a beaker. Inside this beaker, we have, for example, base, and another beaker, we have inside it an acid. Let me say HCl here, let me say NaOH, the simplest things. Let's say that's the HCl is 1 mole over decimeter cubic, and the volume of it is 40 centimeter cubic. And then NaOH is also 1 mole over decimeter cubic. And the volume of it 40 centimeter cubic. Look, guys, to do the experiment and to find delta T, we will do the same thing that we did before. So here, guys, we will measure the temperature of acid or base. Up to you. You can measure the temperature of any one of them, acid or base. You will measure of the temperature of acid or base, let me say acid, for 3 minutes. Okay, for 3 minutes. That and each 30 seconds. Each 30 seconds. For 3 minutes, each 30 seconds. So we'll get such result. Let me say that the temperature was of the acid was 24. So this is the first result, the first point after 30 seconds, after 60 seconds, until we reach to 150 seconds. So as you see, guys, the temperature of acid is constant. At 180 seconds, what we are supposed to do? Any idea?
Do the best line.
We will add the
Like
base.
do that line.
Okay, we will add the base. We mix the acid and base together. Right. So after adding the base, here, guys, we are adding the base here, right, Amel? So after this, guys, what will happen is the temperature start to increase, right? We will wait 30 seconds. We don't measure the temperature here at 180. We will wait 30 seconds and measure the temperature. Let's say that the temperature rises here and continue rising until here. And the temperature later starts to fall down. Why the temperature fall down? As we say, due to the reactants completely, the reactants finish at this point. Right. The same thing will happen here, guys, as we did before. To measure the temperature, to measure the temperature change, we will draw a line of the base fit, and let's say that the line of the base fit reaches here, okay, to 180. The time when we mix the acid and base, so let's say here, 37, for example, 37. So delta T in this scenario will be 37 T2 minus T1, guys. T1 is what? 24. So what will be the temperature, Mariam? 30, right? This is, guys, T2 is 13. Okay, T2 is 13. So now to measure the amount of energy that is produced, what should we use? We use Q equal MC delta T. What is M in here, guys? What is M in here?
40 centimeter.
What is M in here?
We find it from the mole equation, صح?
We find, no, look,
We find the
we
amount.
used
we
40
find
centimeter
from the
cubic of
mole.
base and 40 centimeter cubic of acid. So we add both volumes. This one, guys, is going to be 80. Okay, we will take the volume of acid, the volume of base, adding them together, guys, and we end up with 80. See, guys, 4.18. Delta T was 13. This is a Q. Right. Guys, here, what will be the answer? What will be the product here after multiplying them?
4,347.
4,347.
4,000
347.
47 joule. Okay, the always guys, the unit is always joule. Right, the unit is always joule. Now let's talk about delta H. Delta H, as we said, it is minus mc delta T over n. mc delta T is this, so you just put minus in front of it. N is what? Good question. N is what? Number of mole. Number of mole of what?
Mole is
What do you think?
the concentration
No, it's
times
moles. Moles, but moles
The-
of what?
Of the base.
Why the base? Guys, in here, it is the number of moles of either H plus or OH minus, either one of them, either H plus or OH minus.
It depends on what we added at 180 seconds.
No. You can pick up any one of them. Okay. So as you see here, both acid and bases, they have the same moles and the same concentration. So, sorry, the same volume and same concentration. So we'll have the same number of moles. So in here, guys, could be the moles of acid or base. So let me use the acid, the moles of acid. So we have 1 mole over decimeter cubic, the concentration, equal to the moles, which is X, over the volume, which is 0.04. And you know the reason, we divide by 1000. So X in this scenario, guys, will be 0.04. That is X. X is moles. We take 0.04, substitute it here, and delta H will be, guys, something very huge. The unit of delta H that we found here, guys, it will be joule over mole. You know, guys, this is not acceptable, so we divide 1000, and then we get kilojoule over mole. Okay? Question?
No.
Right. Look, guys, during the experiment, let me remind you, let me show you the graph again. During the experiment, guys, sometimes you will find some points that doesn't fit with the points that we are measuring. For example, let me say that this point, we don't see it here now. Let's suppose that this point we're seeing here, for example, and we continue this way. This, guys, this point that doesn't fit with the previous points, you know what we call it, guys? Do you remember the name of it?
anomaly.
Amazing. You took it in physics, right, Amel? So this point, guys, we call it anomalous point. This is, guys, anomalous point. Why do we have anomalous point, guys? We will have this point due to some problems in the experiment, some errors in the experiment. For example, before we measuring this point, we take the thermometer out from the solution and we put it back here. So we don't get accurate results. We have error. This is one of the sources of the error. Okay. You will be always asked about anomalous point in each what we call this. Whenever you have points, you will be asked, guys, about the anomalous point. You will have definitely anomalous point, and you are asked the reason. The reason, guys, will be given in the experiment. During you read the experiment, you will see something unusual. So this will be the source of error. Okay, this will be the source of error. Right. Now, guys, this is what do we have about enthalpy change of solution. Now we have enthalpy change of combustion. Enthalpy change of combustion. So what was the meaning of enthalpy change of combustion? Simple words. Any idea?
Yeah, the combustion, like something to give carbon dioxide and water.
Yeah, when we combust 1 mole of substance, right? Insufficient amount of oxygen. An excess amount of
Mister,
oxygen, actually. Yes.
do we have to remember these definitions for the exam
Yeah, definitely. You have to know that.
of the enthalpy change?
Yeah. Not all enthalpy changes, but as we took neutralization, solution, combustion. Because guys, I have never, to be honest, I never seen in paper 5 about definition of it, but they have some questions related to definitions. Okay, so you have to know the meaning of them. You have to know that a neutralization is making 1 mole of water. Combustion, it's of combusting 1 mole of that substance. Okay, this is, guys, the setup.
Yes.
This is for memorizing. You should memorize. You should know how to draw this. Everything, guys, here you should know what it is. Okay, this is also, you must memorize it. Guys, in biology we have the shape of the cell, the shape of whatever organs. In chemistry we have these shapes. You should memorize all of these. Okay, all of what I am giving you is important. So how do we do the experiment? We bring water, put it here. We bring the substance that we want to measure its enthalpy change of combustion, put it here. We ignite this. This is, by the way, called Sprite burner. The temperature of the water rises, and we use Q equal MC delta T. Simply, guys, this is how it works. Let's take an example, guys, to understand what's going on. So I will say, guys, we used 100 grams of water. I put here 100 grams of water in here. Okay. And the mass of Sprite burner before using it was 86.27. After using, this is before using it. After using it, guys, we get 0.06. This is after using it. The substance we used here, let me say propanol. We have here propanol, okay? And the temperature rises from 20.2 to 30.9. Okay, guys, this is the temperature. This is the rising in temperature. Let's start with the Q. What will be Q, guys, here? Any idea? M is what? Mass of water, which is what? 100, right?
100 grams.
Yeah,
And
100 grams. And
which is
this one will be for
the specific heat capacity.
yeah,
Yes.
multiplied by the
And then the
temperature
change.
change, which is what? Just minus
10.7.
what?
10.7.
10.7. Are you sure? Yeah, 10.7. So how much it will be? It will be, guys, 4472.6 joule, right? Yeah, joule.
Yeah, right.
Now, guys, let's find delta H. Delta H, guys, equal minus MC delta T. This is MC delta T here. This 4472.6 over N. N is what?
Mole.
Mole of what? Any idea?
Water.
No. Mole of propanol. How many moles of propanol we have? Propanol, which is
We have to subtract.
amazing. Yes. Here, guys, if you subtract this from this, okay, if you minus them, what do we get? What mass we get? We get mass of 0.21.
0.21.
This is, guys, the mass of a propanol that we used. If we divide the mass of a propanol, but its smaller mass, find the molar mass here, you find it 60, it will be 0.0035 mole. This is the moles of a propanol that we used. We take the moles of propanol, guys, which is 0.0035, dividing them together, you end up with a huge number, 1277885.7 joule per mole. This is, guys, joule. This is, guys, ml's number, phone number. So yeah, guys, by the way, as you see, it is joule. So joule is not accepted at all in Cambridge. So we have to convert it to kilojoule by dividing by 1000. So you end up with 1277885 okay, kilojoule per mole. We found delta H. And this is negative, sorry. This is negative, and this is also negative. All of these are negative numbers. Exothermic, always combustion is exothermic. One of the most important questions that 100%, guys, 100% you will be asked about it. They will tell you that in data booklet or in the book, the enthalpy change of combustion was, let me say, -1300 kilojoule per mole, which is huge, more than this. Why is that? Why this number is low? Why the number we calculated in the experiment is low? 100% you will be asked this question. So how could we answer it, guys? Ideas?
Maybe there was an error.
There's
Yeah.
Let's start with Mariam. What, Mariam?
Yeah, maybe because there was an error during the
Definitely,
experiment.
yeah, definitely.
So
We
it
have
resulted
actually
that.
more than error. We have 4 errors in this experiment, 4 errors. So error 1,
Okay.
guys, not error actually. Look, the first of all, heat loss. The heat, guys, the heat will be lost here from this, the heat will be lost to the environment. The heat will be lost to the thermometer, okay? So we have less exothermic reaction due to the heat loss. Guys, another reason, here we are supposing that the combustion of propanol is complete combustion, but we will have some incomplete combustion. So this is another reason we have less exothermic reaction. Evaporating of alcohol. Alcohol, guys, evaporate is volatile substance. Some of it will evaporate. Okay, so this is, guys, another reason. And the last one, guys, the conditions, guys, look, delta H in the book is delta H, this, right, guys? The standard delta H, okay? So the conditions we are working in might not be standard. That's why, guys, we have lower delta H value. These 4 reasons, guys, you must know them, you must memorize them. But let me ask you guys another question. In the previous experiment, the experiment where we did the enthalpy change of neutralization, also, guys, the delta H that we got, the delta H that we got was lower, okay, less exothermic than the delta H of the book. What could be the reason, Mariam? Okay, what could be the reason?
For the previous experiment we did,
Yeah, about the
the
neutralization.
one for the neutralization.
Yeah, when we mix
Yeah.
the acid with base. So this reaction was less exothermic than expected than the book. Why is that? Okay, why is that?
Can we also like say heat loss or
Heat
the
loss.
conditions were not like standard?
Amazing, amazing heat loss. And look, guys. First of all, heat loss, and the second, guys, drawback is when we calculate delta H for acid and base. Guys, the second thing is
So
specific heat capacity that we used. The specific heat capacity that we used was 4.18, right? This
yeah.
4.18 is for water, but my substances were what? Were base and acid, which is not water. So this is, guys, another source of error. That's why, guys, the delta H here is lower than expected, less exothermic than expected. This is, guys, crucial.
So why don't we use the specific heat capacity of the acid or the base?
Why they don't use? Because, guys, look, in the exam you will have a huge table of this, so this will be quite confusing. Okay, each substance has its unique specific heat capacity, so they just Stick to the water. Yeah. Now, guys, one of the most important questions that you never seen before. Uncertainty, percentage uncertainty. So look, guys, if the thermometer is calibrated at 1 Celsius, for example, 1, 2, 3, 4, 5, like this. The thermometer, guys, in our lab is similar to this. So there will be, guys, uncertainty. The uncertainty of this thermometer is 0.5, plus minus 0.5. Uncertainty in this thermometer. The uncertainty is this. How do we get this uncertainty? It is the difference between each two between each two calibrations. So the difference between 1 and 2 is 0.5. The difference between, yeah, the middle, I mean, the middle of them, okay, 0.5. Yeah. Right. So guys, one of the questions that you will be asked about is percentage error in thermometer. Percentage error in thermometer. Percentage error in thermometer, guys, it is always will be 2 multiplied by the number, guys, that we get here. If the calibration is 1, 2, 3, that's this way, so we multiply by 0.5. So here, guys, we have 0.5, for example. Each question has its unique number that we put here. And this one will
be mentioned in the question.
Yes, Maria?
Will be mentioned in the question which one should
be mentioned. Yes, it must be mentioned. The calibration must be mentioned in the question, so you know what is the uncertainty of this thermometer. This one, guys, will be divided by the temperature measured. For example, the temperature was 20 and then it becomes 34. So the temperature measured is 14, right? So guys, this, after you find the, this will be multiplied by 100. After, guys, you find the answer, it will be percent. Yeah, like this. So what will be the percent here? Percentage error, Maria? Tell us the number, what will be? Any idea?
It will be 7.14.
7.14. Yeah. Okay. So yeah, it will be like this. Guys, let's take another thing. Another question. Write with me, guys. This is a question. This is a past paper question. So write with me. A thermometer with a with a graduation of 0.1 Celsius, 0.1 Celsius is used to measure an increasing in temperature from 18.1 to 38.2. Find percentage error. So yes, Emil, how it will be? As we said, 2, we always have 2. We multiply it by what? The calibration is 0.1, right? So yes, the number that we put here is the difference between 0.1 and 0.2, which is 0.05. The thing in the middle between them. What is the middle between 0.1 and 0.5? 0.2, 0.05. This one, guys, will be divided by the temperature. Guys, the temperature was 18.1 and increases to 38.2. What's the difference between them?
20.1.
20.1, right?
Yes.
Multiplied by 100%. And what will be the answer? 0.49%.
Yes.
Look, guys, always in this type of a question, the uncertainty question, guys, the temperature, the percentage error, guys, should be given to 3 significant figures. Always 3 significant figures. Always 3. Okay. Guys, look, we see here we have a very important note. When the temperature increases, guys, when the measured in temperature, when it gets larger, when it increases, what will happen for the percentage error? Any idea? When the temperature increases. So what will happen, guys, for the percentage error?
It gets smaller.
It decreases, right? Yeah, decreases. So this is, guys, very important. Right. Until now, guys, here we finished this topic, the enthalpy. This is all you know. You must know about the enthalpy. Our next class will be about rate of reaction. So goodbye.